Hello, everyone. A very good afternoon to all of you, dear authors and invited guests. Welcome to the technical session 9B. Myself, Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 9th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2024, Goa, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized yesterday in Goa, India, and the virtual event was held yesterday and is being held today, that is 8th and 9th of August 2024, through Zoom. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations, and each presenter will be given 8 minutes for the presentation and 2 minutes for the question and answers. And on 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we start this session, I would like to introduce you all to the chair of the session, Dr. Anuradha Yankikar. She is currently working as an assistant professor at Department of CSE Artificial Intelligence at Vishwakarma Institute of Information Technology, Pune. She has published more than 30 research articles in reputed journals with the CSIE Web of Science Scopus Indexing. She has also published many books, chapters, and patents. Her research interests include data science, machine learning, artificial intelligence, deep learning, and parallel computing. So I welcome you to the session, ma'am.
Thank you so much, Anisha.
Okay, so now we'll begin with the papers, and our very first presenter is Rushin Bhatt with the paper title, A Detailed Exploration of the Security Issues in Educational Applications. So Rushin, are you there in the session?
Yes, I am there.
Okay,
Just a
so you
second.
may begin with the, yeah, sure.
Yeah, I'll just share my screen. Yeah, is it
Yes,
visible?
the PPT is visible, yes.
Yes. So, hello everyone. I'm Rushin Bhatt. I'm currently in my fourth year at PDEU in Gandhinagar, and I'm studying computer science. So, our review article focuses on the security measures and issues specifically in the education sector. So first, let's understand what exactly network security is. So network security is a very basic element of computer science, and it consists of a wide range of technologies that are used in different ways. Like the two main goals of network security would be number one, data protection. So to prevent breach of data, and it acts as a digital bodyguard to ensure the safe transfer of data between the sender and the receiver. So before we come to the system architecture that we've built, I would like we've considered three things to eventually build the system architecture. The first one is the types of attacks that a system could go through. So the first one would be a phishing attack. The second one would be a malware, denial of service, and man in the middle. And man in the middle is where there's data breach between the sender and the receiver. Then to come to the emphasis on the education sector. So firstly, in educational institutes like universities and schools, campus area networks would be the preferred network that would be used. And we focused on number one, the vulnerabilities that the system could go through. Second, what measures we can take as part of the cybersecurity. And three, the prime targets within the system. And in this, the second thing we considered was how these threats can be prevented. So, number one, the students can be more cautious of how their data is being used and using the systems within the campus. The second one would be the use of emerging technologies like AI, ML, deep learning, etc., to ensure cybersecurity. The third one would be using traditional cryptographic algorithms, so cryptography, to ensure data security and security of the information being transferred within students, teachers, etc. So here is our system architecture. Is it clearly visible to everyone? We've created an ER diagram to represent it. Yeah, so as part of this, the rectangles represent the entities, the ovals represent what the entities contain, and the diamonds represent the relationships between the entities. So central to the system is the portal. And for example, portal would contain a database. Portal would be used and updated by the accountant. A parent would transfer the fees to the accountant that eventually is being transferred to the universities or institutes bank account, etc. And similarly, we've mix and match every entity possible within an educational institution. Now, coming on to the algorithms that we can use, we have considered four algorithms, DES, 3 DES, that is three times the same DES being used with a different key, AES, and the last one is RSA, that is made up of three scientists' names. In conclusion, we have considered all the security measures along with technologies like AI, ML, DL, and cryptographic algorithms to ensure a safe online learning space. Uh, and yeah, I think this is it.
Yes, thank you, Rishi. Do you have results part? Please show.
It's we so it was not exactly a results part, but we've proposed a system architecture.
Okay, so results means this model is you have not evaluated, right?
We have not deployed this, but this is a proposed one which we will be eventually deploying in the next few months.
Okay, so have you tried simulation of this model?
No, not yet. So that this is precisely the reason we considered this a review over a research article. So
Okay, so what would you describe, like what could be the real contribution of your research?
how do I put this? The model can be built and deployed on the cloud, and it could be probably sold or proposed to many universities or schools that they can deploy to their particular system and use it for all their students. So, suppose if a teacher gives out the results to the students, the results can be directly updated to the portal instead of physical mark sheets.
Okay.
Yeah.
Okay, thanks, Rishi.
Thank you so much.
Yes, Anisha, we can move forward for the next one.
Sure, ma'am. So moving on to the next presenter, we have Bushra with the paper title Brain Tumor Detection Using Extreme Learning Machine.
Yes, ma'am. I'm present here.
Okay, ma'am, you may begin with the presentation, ma'am.
Okay. I'll begin. First of all, good afternoon, everyone. Present here. My name is Usha Tiger. I am from KD Technological University. So today our topic is detection of brain tumor using extreme learning machine. Okay. So first of all, starting with the motivation of the project, as we all know that ethics it accounts like for approximately 10,000 individuals, and even in India, quite more for that very good for this kind of experiments. We provide a new knowledge of machine learning that is an extreme learning machine. Basically, extreme learning machine means that it consists of three layer. There are many other deep neural network or other type of, but one lacking factor is that more number of hidden layers, but we try to implement this concept of identifying brain tumor using extreme learning machine, which means it has only one hidden advantages. As I was discussing all the advantages. Coming to the third, that is simplicity. ELM has architecture of ELM is quite straightforward. It consists of one input layer and a single hidden layer with random weights and outputs. ELM can generalize well with noisy training data, enhancing the robustness. There are several other advantages, which includes simplicity, robustness, and everything. And then I move on to the next slide. The problem statement was we got a problem statement to develop an accurate and efficient methodology for detecting brain tumors that will help the medical faculties to make better diagnosis towards this disease identification. So objectives achieved in this project are implementing ELM for brain tumor detection. Second is optimizing the ELM model, and third is evaluate and compare the performance of existing or proposed methodology with other pre-trained models like ResNet VGG16. This is the high-level design, wherein we have the input image in the form of MRI or CT scan images. We perform the data pre-processing using like noise reduction and resizing of the image, and the output that we get from data pre-processing is pre-processed brain images, and we put this pre-processed data into a feature extraction, that is GLCM, so that we could get some accurate to get some good features that will help in accurate diagnosis and identifying of the disease. First one is after this feature extraction, we move towards splitting of the data into training set and testing set. Train the ELM model using feature vectors and label. That is what we achieve the training set by extracting the features from the GLCM, and then we perform the testing, and the model implementation is done using ELM. Next, we get the output as healthy or diseased. This is the high level design of ELM, which this whatever, this is the input layer, and this is one single hidden layer. The input layer is interconnected to all the hidden layers, and from here it gets processed and goes to the output layer, and here we can identify whether it is diseased or whether it is healthy. This gives the dataset description here, a detailed dataset description. This is an example of the images. Dataset comprises of 253 JPG images, out of which healthy consists of 155 and healthy consists of 98, and this is consists of 155 images. And size of dataset is about 16 MB. Modules that implemented during this project is first is data collection. We collected brain MRI images from Kaggle dataset. And second is we performed image pre-processing, as I said, resizing of images and image denoising. And third is achieving feature extraction using gray level co-occurrence matrix. And then third is implementing the ELM model. Here primarily we implemented the kernel based ELM, and then training and evaluation. We evaluated we trained the ELM model and evaluated its result, and also compared it with some other existing neural network models. And then lastly, we did result analysis of how much of accuracy, precision, and F1 score did we achieve during this training. Okay, this is a detailed explanation of what is GLCM. Basically, it is one of the most widely used methods for extracting features when we are doing when we are trying to implement certain models for image processing. So we extract the features, feature function computes gray level co-occurrence matrix features for each given image. These features like include contrast, energy, or homogeneity, correlation, and several other kind of factors with distances and angles. So we kept the distance as 1, 2, and 3, and angles as 0, pi by 4, pi by 2, and 3 pi by 4. For each distance angle combination, the function extracts 5 features. This is related with respect to one image. We have kept 1, 2, and 3 distance, and then angles were 0, pi by 4, pi by 2, and 3 pi by 4. For each distance angle combination, the function will extract 5 features. Then given there are 3 distances and 4 angles, the total number of features extracted from it will be 3 into 4 into 5, that will be 60 features are extracted for each image. Therefore, the code will extract a total of 60 features. This is the computational complexity of ELM, wherein we achieved an accuracy for kernel-based ELM as 77.14%, precision as 0.81, recall as 0.72, and F1 score as 0.76. This is the computational complexity analysis for kernel-based ELM. So N indicates the number of images and M indicates size of each image. P means complexity of GLSAM feature extraction. K means number of features. L is number of test instances. So this is the time complexity that we got for each component here. This table shows all these components and their time complexity as well as space complexity analysis. For feature extraction, we got O(n) into M into P. And then for complexity, for space complexity, we got O(n) into M into P again, which is average. Average complexities. Then for data pre-processing, we got O into N, and space complexity also O into N, where we didn't use any auxiliary memory for analysis of space. So it is N. And data set splitting and standardization is OK into N, which means number of features
Please
into
move forward.
number of images. And
Yeah,
yes,
please move forward.
okay. So this is the result for ELM using sigmoid functions. Based on the activation function, this is the graph that we achieved.
Okay, next.
Functions. This is a comparison analysis for different models that we used. Your ELM has a high accuracy, and VGG has lower accuracy outcome, and ResNet will have a notable accuracy. We implemented the we stopped the we implement stop box at 28 for ELM, and for VGG 16 we stopped the epochs at 34th, and for SNet we gave some random epochs, so that's why we choose 28, 34, and 38 the epoch and stopped at that. So we got a result accuracy of 82% for ELM, and VG 16 73, and for SNet it's 72%. Conclusion it is far efficient.
Disconnected again.
Yes, yes. I think we will restrict to time also.
Yes, ma'am. We'll move to the next one now.
Yeah, sure, please.
So next we have Priyanka with the paper title Detection of Age-Related Macular Degeneration Using Machine Learning and Deep Learning, a Systematic Review. Ma'am Priyanka, you can
Yes,
start your presentation.
yes, I'm sharing the screen.
I beg your pardon. I lost a connection again. I'm very sorry for that.
Yes, no problem, Preetham. Just wanted to ask you one question.
Questions one.
Uh, are you sharing something?
Yes,
Should I
yes.
stop
I
sharing?
was.
Yeah, please. I think she want to present something.
Okay.
I was just telling the conclusion and the futures of the project. As I said in the earlier slide, advantages of ELM. And the advantages of ELM, the models as it is fast, simple, and it can be easily implemented. We got a result of 82%. But if you try with some other efficient some other fields as well, wherein it will give higher accuracy rate, for example predicting of weathers or predicting of any disaster or something like
Yes,
that.
Preetham. Yeah, please.
And this
Yes, wait, please. So basically, yeah, I understood what is your research paper is about. Just wanted to ask you one question: how effective this ELM model is as compared to the traditional methods like convolutional neural network, SVM, and all? Because you have referred ELM model with ResNet and one more model, right? So,
yes
have you checked it the comparison with the traditional methods?
yes ma'am, we have so
Mhm.
one like as I've discussed the advantages of ELM, it has the ability to explain the complex processes that underline the persuasion.
Okay.
And ELM, it is also an very easy and basic model. It does not require heavy computational resources to be implemented. As you can see that various other neural network models would require certain computational resources, and they are heavy model because they consist of more number of hidden layers, and you get the same accuracy of 80%, 90%. So I have, if I have to conclude about ELM, I can say that we could combine ELM with some other better methods to obtain a good accuracy while maintaining the same computational resources of the like of the environment.
Okay. Yes. Thank you, Preetham. We will move forward for the next paper.
Thank you very much, ma'am. Thank you.
Yes. Thank you so much. Yeah.
Okay, sharing my screen.
Yes, please.
Is it visible?
Yes, it is visible.
Okay, good afternoon, everyone. I'm Priyanka Bulhane. Today I'm presenting a paper on detection of age-related macular degeneration using machine learning and deep learning, a review paper. So starting with the introduction, as we all know that eyes are the highly developed sensory organ of a human body. So the larger part of the brain is dedicated to the function of eyesight than that of other sensory organs like smell, touch, taste, or hearing. According to the WHO survey, almost 285 million people are visually impaired. Out of those, about 12.3% are affected by the disease like glaucoma, 8.7 are affected by the disease ARMD, and 4.8% people are affected by the disease diabetic retinopathy. Human retinal images have gained an important role in the detection and diagnosis of many eye diseases like diabetic retinopathy, age-related macular degeneration, cataract, glaucoma, microaneurysm, macular hole, and many more. So many eye abnormalities are clearly visible in the retina than any other part of the human eye. A growing number of retinal disease patients, hospital expenses, and scarcity in number of ophthalmologists are the barriers to achieve the recommended screening in the patient who are at the risk of retinal diseases. So, developing a system to diagnose retinal diseases with image processing technique is solution to this problem. The motivation behind selecting this particular topic is, as we all know that due to COVID-19 pandemic situation, most of the people, they were doing their work from home on different online platforms. So because of that increased screen time, many people are suffering from eyesight issues. Further, the people having visionary issues, they are more likely to prone to other diseases like diabetes, heart-related problem, high blood pressure, stroke, and many more. Again, the third concern is the doctor-patient ratio in India, which is 1 is to 10,000, which is not a good ratio. I mean, it represents that behind a 10,000 patient, there is only one doctor to treat them. Then the number of patients affected by the retinal diseases are increasing day by day. It is the need of an hour to develop an automatic screening system for diagnosing retinal diseases. Early diagnosis and management are crucial to mitigate impact on visual functions and quality of life. Then importance of early diagnosis. Prevention of severe vision loss. So early detection of ARMD or age-related macular degeneration allows timely intervention, which can slow the progression of the disease and help to prevent prevent severe and irreversible vision loss. Then improved treatment outcome. Early diagnosis increases the chances of successful treatment, as certain therapies are more effective when they are administered in the early stage of AMD. The next is cost-effective healthcare. So here, early diagnosis or intervention can reduce the long-term healthcare cost, which is associated with the advancement of the diseases. Then next, slowing the disease progression. Early diagnosis will again allow the clinicians to monitor the disease progression more effectively and adjust the treatment plan as needed, potentially delaying the onset of more severe form of the AMD. There are multiple types of eye images, which we can experiment with. But here I'm focusing on OCT images. So why OCT? Because it provides the cross-sectional image of the retina, allowing for detailed visualization of its layer. So OCT is a non-invasive, quick, and relatively comfortable procedure for patients, making it ideal for regular monitoring. OCT technology is continually advancing, leading to the new insights into the pathophysiology of ARMD and the development of novel therapeutic approaches. So this is a sample OCT image. The first image is an OCT image of a normal eye. So this white line is a kind of continuous line without any abnormalities in it. So it is an OCT of normal eye, and second one is an OCT image of a eye which has drusen. So these abnormalities are called as drusen. So this is an affected eye, that is age-related macular degeneration eye OCT image. So as this is a review paper, so these are the different techniques which have been already used for different categories. For classification of the image into disease, no disease, SVM, random forest, AdaBoost, CNN, LSTM, these algorithms have been used. And to check the severity, SVM, LSTM, and Catalyst is used. And to categorize into wet, dry, and normal image, naive biased, CNN, KNN, decision tree, and SVM algorithms have been used. So here I have categorized my literature review based
actually,
on.
since it's an image processing based project, right, for research,
Yes, yes,
actually in the and it is also a review paper also, so you can explore even the transformer based models or even variants of convolutional neural network, or even such technologies like quantum net and quantum technologies, quantum computing,
yes.
for such kind of project that will give, that will enhance the more evaluation performance.
Yes, as it is a review paper, I have not displayed my results here.
No, that's okay.
Uh,
For future, you can explore those.
Yes, I have seen the transformer clip model, which can
Okay.
find out the embeddings from image as well as text. But as it is an image related thing, so clip I have explored. Is there any other model which you would like to suggest me for further exploration?
Yeah. Quantum computing is also best one for such, medical image related study. That
Okay.
will really enhance the performance of your model. So you can
Oh,
explore even that part also.
yes, I'll do that.
Sure. Okay.
Thank you.
Please go ahead. Yeah.
So here I have categorized this literature based on the techniques. So CNN-based analysis initially. So by CNN, it is so convolutional neural network are a class of deep learning algorithms that are particularly powerful for analyzing visual data. So in context of eye disease detection, including AR&D, CNN have become a key technology due to their ability to automatically learn, extract features from the medical images. Again, CNN automatically learns to identify important features from the raw image without the need for manual feature engineering or extraction. And they are well suited for processing large amount of data and which are often necessary for training the model to detect the difference between the differences in medical images. CNN can be integrated with other machine learning models or techniques such as SVM, LSTM to enhance the diagnostic accuracy. So these are the papers where they have used a CNN model. So in my first paper, they have used the data set from Department of KMC Manipal. They have used custom designed a CNL model with back propagation and batch size of 50. With this, they have achieved, this is the performance they have achieved. The accuracy 91.17 with blindfold and 95.45% with tenfold cross-validation. In second paper, they have used ODIR 5K dataset, a plain CNN model.
Here only I was talking about. See, instead of means traditional CNN model, there are a lot of variations coming in the CNN, like
Like
ResNet,
ResNet. Okay.
DensNet, yeah, DensNet, VGGNet. Even you can check YOLO latest version. That is
Okay.
also suitable for such. In fact,
Okay.
GAN is also there, generative adversarial network, so that you can explore as a part of your, further research. That for now it is okay. Yeah,
Okay.
please go ahead.
Can I ask one question?
Yeah, tell me.
Whatever I have read and small experimentation I have did with GAN, it is used for image generation, right?
Yeah, image
So
generation for
where can,
augmenting your training data. Means suppose
okay,
basically creation of synthetic retinal images.
yes, because many times the data is imbalanced. We have less images of a
Yes,
disease
yes, yes.
affected. Okay,
That
yes.
time we can use, yes.
Okay, thank you. Then in second paper, this is the performance they have achieved. In third paper, they have used a Kaggle dataset, and they have used a CNN with parameter tuning and cross validation. And with that, they have achieved an accuracy of 80%, confidence in the range of 59 to 77 for glaucoma, and for diabetic retinopathy, 58 to 72%. Then in next paper, they have used Nagoya City University Hospital dataset, and they have used
Fine, fine.
CNN
Please go
model.
ahead. Next one.
Okay. Again, these are few more papers
Okay, please
on
go ahead.
CNN only. Then we have next algorithm, that is
Traditional
SVM.
methods, SVM based. Okay.
Yes. Should I go ahead?
Yeah, yeah, please go ahead because it's yeah,
Okay. So these are
SVM
the
studies.
papers we have.
Okay.
They're using the SVM, and
So
these
how
are
many
the
papers in total you have referred for this review paper?
more than 100 I have referred.
Okay,
But
that's
we
great.
categorize them into this. So here in this presentation, I have listed less than 30 papers.
Okay, 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 fine. Please go ahead.
Then
Okay,
next approach is
random forest,
random forest
Sorry for the
gradient.
interruption, ma'am, but
Yes,
actually, can you please conclude your presentation as you have
Okay,
exceeded the time limit?
yes.
okay. So I'll just go to this in conclusion. So each method brings a distinct advantage to AMD diagnosis. So CNN automate feature extraction. LSTM handles temporal data effectively. However, they also pose a challenge such as computational complexity, interpretability issue, and so on. Gradient boosting algorithm improves the classification performance and model generalization. The interpretability of random forest model allows the clinicians to gain insight into the feature contributing to ARMD detection. SVMs have been utilized to handle high-dimensional feature space. Finally, the choice of method depends on the specific characteristics of the data set, the problem domain, and the intended application in clinical practice. So in this survey, many techniques have been discussed for ARMD detection, and many IDCSs are asymptomatic at its earlier stage, and hence constant screening, precise and early diagnosis of IDCSs is required. Further research direction could focus on refining the hybrid methodologies, exploring novel ensemble techniques, or developing an explainable AI model for further interpretability. So all these methods continue to evolve. Their collective impact could significantly improve early detection and management of AMD, leading to better patient outcome. So these are all the references. Thank you.
Yes, thank you so much. I think we can proceed further for the next one.
Thank you.
Sure, ma'am. Thank you so much for
Yes.
the presentation.
Thank you, madam.
Moving on to the next one, we have Piyush Bora with the paper title Enhanced Online Proctoring, Leveraging Client-Side Deep Learning.
Yes,
So
good
Piyush, you may
afternoon,
begin with
everyone.
the
Am I
presentation. Yeah.
audible?
Yes, you're audible.
Okay. I'm just sharing screen. I hope that's visible.
Yes, it is.
Okay. So basically, my presentation point is enhanced online proctoring system. Um, Me and my team have been working on the problem statement of providing a user-friendly online exam proctoring system, which basically works on the client side, unlike the existing systems which actually process on the backend servers and databases. We try to reduce the intensity and extensiveness of the database or the storage levels that we require, and also bringing in some also handling some malpractices which were actually happening currently. So our very first objective was to handle the exam integrity and bringing real-time monitoring to stop the cheating attempts. The second one was client-side execution of the AI models. Now, what generally happens is that whenever we try to give some online exams, which have been very common in the recent times, even after COVID, so in these models, in these websites, we actually have the entire recording of the exam duration to be sent on the backend, and the backend then actually processes it after some time. And this is the general flow of the website there. But in fact, to reduce the data we actually store, we have come up with a approach which actually happens on the client side. The third one was to provide a user-friendly experience in which we ensure that both the test takers and the proctorers, or the one who is setting the exam, have got complete flexibility over the platform. We will be providing more than 3 or 4 types of question and answers, which could be set by the exam taker, and the test takers can take the test into some fixed duration. Even the exam taker can actually add people who are eligible to take that test. The fourth most important point is that we detect extensions which can override some of the restrictions that the website or the platform actually performs on these systems. Then we have multiple types of questions supported, and we try to save the storage of the user. Let's move on to the system architecture. Here we are comparing the existing architecture with what we have proposed. So the first one, we see that there is a backend server in which actually collects the combined output of face verification, object detection, and exam computation, and that is then given from the client browser actually. This combined output then goes to the backend server and gets stored in the database, from where it is fetched periodically and it is processed. once it is processed, it can be periodic between the exam times also, and that can be sent to the client browser again. But by the time this data is sent, it can be like that the client who is using it is already included in some kind of malpractices and has already been doing it. In this case, we can't actually ensure that the client has to stop the exam in at the very moment that he engages or he or she engages in some kind of malpractice. What our system provides is that we have everything happening on the client side itself. In the client browser, we have these TFJS models running. TensorFlow JS library has been used. In that, we have these face detection and object detection models. That those models can send their output to the client browser itself. Those malpractices can be sent as an event, and that event can be recorded into some output in the backend server and can be stored in a database. Once it reaches for some kind of threshold of the malpractices happening, maybe 3 or 5 times could be allowed. After that, the exam has to stop, and the client should not be able to give the test further and should be disqualified. These this actually saves a lot of data that is stored on the database. What we are doing is that we are just saving the instances when there is a malpractice detected, and that malpractice screenshots are then given to the database where it is stored, and a dashboard can be made where these malpractices or the screenshots of it happening can be stored. This object detection can actually have mobiles or some other stuff, and the face detection can have faces detected, multiple faces detected, and that is how the screenshots are taken and stored in the database. Once 5 times or 3 times is over, the client browser will get the examination will actually get a variable set, and that variable is stored in the local storage basically. Once that variable is set, that time the exam gets disqualified. So the client gets disqualified and the exam stops abruptly, and that client message is then given out. So instead of storing the entire video data in the backend, we are just storing images here. So the very first feature is extension for extensions, and actually our competitors are doing it by actually giving out different browsers. They are actually investing a lot of cost into this, and a different software, different browsers are made in which they ensure that no external JavaScripts or other things are can try to actually surpass the restrictions they have made. Now, what restrictions can be surpassed is that first one is the full screen modes, and that even the exams can be taken without full screen modes, and that this is something that should be avoided. Second is active windows on the client browsers. Basically, the client browsers can actually have this.
Yeah.
Yes.
In these features, is there any role of artificial intelligence, AI or deep learning, anything?
Yes, so basically, when we detect client side, when we talk about client side detection, it actually detects faces, objects, and such other things from the client side itself. So there we have been
Okay, so
using machine.
which methods? Yeah, tell
Yeah,
me.
for the face detection, as I said, we are using TensorFlow.js library, and for
Mm-hmm.
object detection, we have been using MobileNet.ssd.
Okay.
Yes,
Okay, please
these
move
are
on. Next slide, please.
yes. The basic use case diagram is
Okay,
here.
fine. These use case diagrams are okay. Please move on.
Data flow in our app.
Next.
Yeah, there are some references, and then
Okay, so is it at the preliminary stage? Means, have you received any results?
yes, we have made this software entirely, and this website is actually not published yet, but it is with us. We have taken it as an implementation for our final year project, and
Mm-hmm.
it actually runs in this manner itself, where all of the processing is done in the front end. It gives output to the React app, and that application then sends only the screenshots or the suspicious score to the backend server. Then, if the
Mm-hmm.
score is after a threshold, like suppose 3 or 5 times is allowed, uh, and then if that score surpasses the malicious score, then we actually give a message that the client has been disqualified and not allowed to give the exam ahead.
Mm-hmm. And how you are training your model with the help of a real means live video or any
No, no,
existing
no.
videos
So
you are using?
So basically, when the student arrives here, he is allowed
Mhm.
to, log in. And while log in, he can also register after register. When he's registering, he has to fill an online form, which actually captures three images of the person. The
That part I understood. I am asking you the question for training your model, AI-based model. You suggested, I think, mobile net you are using, and which one you said? The next.
MobileNet is for object detection, and TensorFlow JS is for the face detection. So
Mhm.
actually, that is what I was telling, that when we fill the online form, images are taken, and on basis of those images, this model is trained.
Okay, fine, fine, fine. Got it. Okay,
Yes.
please. Yeah, thank you.
Yeah. Yeah, that's it. Thank you so much.
Okay, thank you, Piyush. All the best.
Thank you.
Thank
Yeah,
you for the
Anisha, can we move on?
presentation. Yeah,
Yeah,
sure,
please.
ma'am. So moving on to the next presentation, we have Vatsal Mehta with the paper title Enhancing Spam Email Classification Through Ensemble Learning, Smart Oversampling and Hyperparameter Tuning.
Yeah,
So Vatsal, you may start your presentation.
yeah. Am I audible?
Yes, you are audible.
Yeah, I will just share my screen. I hope the screen is visible. For the introduction, I will have my partner Soham to just start with the topic.
Yes, good afternoon. Is my voice audible?
Yeah, yeah.
Yeah, okay. So, as visible, our topic is enhancing spell email classification through ensemble learning, smooth oversampling, and hyperparameter tuning. So, the basic necessity of choosing this as our topic, as we know, spam is one of the biggest platforms to share information, and it is heavily misused as well. We wanted to project basically a program which will where we'll be able to between actual emails and ham emails. This more efficient classification would lead to less cyber attacks, and it will make the more secure.
Yes,
So that
please
is,
move on.
yeah, okay. So Vatsal, can you take over?
Yeah,
Yeah, please go to the this one methodology or wherever your contribution is. Skip this
uh,
introductory part of what is spam classification and all. Okay.
sure. So, starting with the propose method, what we saw is that the other machine learning ensembling models and ensembling classifiers combined with the hybrid ensembling learning were able to contribute more to the spam email classification. So, we also thought that we can also use different ensembling models such as bagging, boosting, and stacking and voting to classify more further to and also reduce the redundancy of the this minority oversampling and majority oversampling in our data. So we have a spam data set in which we have 5,000 more than 5,000 records, and these are into the target and text format, which in which the target defines the ham and spam of the specific text that has been proposed to the email. And starting with the step one, we propose that we have data pre-processing in which we are using NLTK library. And in this NLTK library, we are processing the text to lowercase and also performing tokenization, stop word removal, and stemming. And after data processing, we had to move the vectorization of to calculate the email classification into major transform model. So for that, we have used the term frequency inverse document frequency, and which is also abbreviated as TF-IDF. This method is executed on the relevance of the word concerning the entire data set. Further, to reduce the bias towards the one class, we have used MODE, which is synthetic minority oversampling approach, which indulges in generating artificial data points of the minority class. To accomplish this, it selects a minority class sample, basically in our case, a spam sample randomly, as the spam data is less then the and ham is the majority. So we calculated k nearest neighbors classifier of the sample and are found to interpolate between new synthetic instances. Further, to start with the ensembling classification, we have used bagging, boosting, and stacking and voting. And bagging, it is we have to work for fitting and reduce it. So for that, we are using the clusters which are trained in parallel processing, and their outputs are independent of each other. So bagging was also performed using two ensemble classifiers, which is decision tree classifier and random forest. And with that, we just got accuracy of like 95% and precision of 100 and recall of 82%. Further, with the random forest, we also got a bagging of accuracy of 97, 100 for precision, and recall for 82. So we thought that we can also improve the model. So we just tried with the boosting. And boosting, we are using AWS algorithm since it works very well with binary classification problem. With AWS, we again tried with decision tree classifier and random forest
Which
classifier.
data set you have used here?
Spam email classification from Kaggle.
Okay, from Kaggle. Okay.
Yeah.
Okay, fine. Move on. Fine, this is all
So
observation. It is okay. Next slide.
yeah. So and finally, we just found that after all the approach, we just found that voting is supports well for the final prediction. As in voting, there are also two parts like soft and hard voting. So hard voting is basically made on the total votes, and soft voting is based on the probability scores on the all classifiers. For that, we have used SPC, XG, boost classifier, multinomial naive Bayes, and random forest classifier. And we are just providing the uniform limits, estimators, and max depth and tree length according to it. And just found a result that voting ancestral gave a precision of 97%, outperforming approximately 5% compared to the backing boosting on the basis of recall. So final result for the voting, we just found like 97% in both accuracy and precision, and for 87% in recall, which was 5% greater. So to further increase the rate of classification, we also use a fine tuning method on this voting classification. We did fine tuning on the basis of random forest classifier, and also found that result that all the accuracy, precision, and recall were 98%, which was the best till the date that we have found. So, what future scope was that we have only used the text data that has been processed for the spam. So, for dataset that includes multimedia content such as documents and emails, and the documents can also be reviewed for better accurate results in real world problems. Thank you. These are the references that.
Okay, so basically it's all experimentation contribution. Okay.
Yeah, right.
Yeah. Okay. Yes. Thank you.
Thank you so much, ma'am.
Yeah. Can we move on
Thank
to
you,
the
ma'am.
next one? Yeah, please.
Sure, ma'am. Thank you for the presentation. Moving on to the next presentation, we have Avinash with the paper title Health Monitoring for Parents Away, a wearable IoT solution for rural and urban areas. So, Avinash, you may begin with your presentation.
Okay, ma'am. I'm audible to you,
Yes, you're audible.
ma'am. Okay, okay. My screen is visible, ma'am.
Yes, the screen is visible, but the PPT is not. Yeah, now it's visible.
Okay. Good afternoon, ma'am.
Good,
So, Neha, please start.
okay. Good afternoon, everyone. My name is Neha Bokpode, and I am here along with my co-presenter Avinash Andhare from GSPM Rajeshri Shahu College of Engineering, Pune. Um, Today we will be discussing our paper Health Monitoring for Parent Away, a wearable IoT solution for rural and urban areas. Next slide. Next slide.
Yes, I can change.
Introduction. In in today's world, the Internet of Things or IoT has made its way into nearly every sector, be it industrial, educational, agriculture, or healthcare. In the medical field, we are seeing a growing number of wearable devices like fitness bands and smartwatches that can track health metrics. Um, However, these devices come with risks. Our project focuses on monitoring the health of parents, especially when their children are away due to work or other commitments. While hospitals provide health monitoring, this service is usually limited to hospital settings and requires the presence of doctors. Um, once the patients once the patients leave the hospital, this continuous monitoring stops. Our solution process of wearable IoT devices designed specially to monitor the health of parents remotely. Next slide. A literature survey and problem formulations. In that, our literature survey, we reviewed several key studies related to IoT-based health monitoring system. First one is Smart Healthcare Monitoring System based on IoT, IEEE in 2021. This study focuses on integrative IoT into healthcare, but mainly within controlled environments like hospitals. Second one is IoT-based health monitoring and analyzing system using ThinkSpeak Cloud and Arduino. Uh, this paper explore IoT for health monitoring using cloud technologies, but the system complexity and cost were now noted challenge. Third one is ICT-based health monitoring system. This research emphasizes the uses of ICT in health monitoring, but lack real-time tracking for remote care. Fourth one is real-time healthcare monitoring and tracking system using GSM and GPS technologies. This study highlighted the potential. Um, this study highlighted the potential of GSM and GPS for health tracking, but was limited by the need of constant connectivity. Next slide. Objectives. Our paper objective has four primary objectives. First one is remote health monitoring. We aim to develop a system that allows for continuous and remote monitoring of parent health. And this ensures that their well-being can be tracked even when their families members are not physically present. Uh, Second one is alert mechanism. The system is designed to alert the use their families members or guardians immediately if any abnormalities in the health data are detected. This can enable quickly response in case of emergencies. Third one is real-time vital signs monitoring. We aim to provide real-time readings of critical vital signs such as heart rate, SpO2 levels, and body temperature. These are initially essential indicators of person's health status. Fourth one is cost effective and energy efficient. Finally, our goal is to make a system both low cost and energy efficient, making it is accessible and sustainable for long term use. Next slide will be explained by Avinash.
So next slide is the proposed system. In our proposed system has three main parts. First one is hardware, second one is cloud, and third one is a mobile app using the React Native. In the hardware stage, different sensors like temperature, SpO2, and heart rate are connected to the ESP8266 microchip using the Arduino IDE. The microchip collects health data smoothly. In the second stage, ESP8266 module connects to the ThingSpeak cloud through the ThingSpeak API, where data is visualized as a graph on the ThingSpeak website. Data security is maintained with unique API key. In the final stage, the processed data is sent to a React Native mobile app for Android as well as iOS, and this data sent through the ThingSpeak API. The app has easy to use interface with logging and home screen that shows the health data with a circular progress bar. If there are abnormal readings happen, then this app show the alert message to the guardians.
Can you move to the methodology?
Yes, here is a system architecture, ma'am. So basically, this is a hardware device. This ESP8266 module. This collects all the data from the sensors using temperature, SpO2, and heart rate sensor. This sensor collects data from the human body, and this data sent to the ThingSpeak server using the API. This ThingSpeak is a open source cloud, and it's free to the student use. So we can also visualize this data on the ThingSpeak server. And here is the build app using React Native. This React Native app, and write the backend code in the using Node.js. So basically, this ThingSpeak server send the data to the app using ThingSpeak APIs. APIs too. If any abnormal condition is happen, then that time show the alert message to the app. So here are our system architecture. And next one is a conclusion. Our research is a health monitoring system with a IoT-based system designed for families separated by the work commitment and is away from the home. This system is a three-part, particularly using
Okay.
hardware,
So
cloud, and mobile application. Okay, ma'am.
yes, please. Why you have used this ESP8266 microchip? Why you have selected this one only?
Okay, ESP266 microSys is cheap, very cheap. Its price is only 400 rupees. Over to the Arduino. Arduino basically Arduino price is 1500 and 2000 like that. So make it's a cost effective. So we are using here ESP266. Also, it has a less consume power as compared to the other microchip in the market.
Okay,
Yes, ma'am.
fine. Is this last slide, right?
Yes, here is some result and some screenshot of our application. Yeah. Here is a home screen and here is a login page like that. So, and here take some references from the.
What is the tech stack you have used for development of your application?
Here is a basically Arduino. I use C++ for the hardware and React Native is for the mobile application. Ma'am. So here I. So thank you, ma'am. It's all about my project. Hello, ma'am.
Yes,
Yes,
thank
okay.
you for the
Thank you so much.
presentation.
Yes, please move on.
Thank you. Thank you, ma'am.
Moving to the next presentation, now we have Sarang with the paper title Image Restoration for Heritage Places Using GAN.
Yes, wait a minute.
You may proceed with the presentation now.
Yes. Is it my screen visible?
Not yet.
Okay, wait a minute. Is it visible?
Yes,
Yes,
it is
now it
visible.
is.
Please move on.
Okay, thank you. Okay, good afternoon all. My paper title is Image Restoration for Heritage Places using GAN. So the broad area of research is image processing. My name is Tarang Bohrupi. So content of my topic is we see why we need the image imprinting, then need motivation, some challenges we are facing, while restoring the images. Then literature survey, some objectives, then methodology. In methodology, we'll see the GAN architecture. What are the performance metrics I have used to calculate to measure the performance of the GAN? Then results. What are the advantages, disadvantages? What are the upcoming application of the GAN? Then finally references. So we'll see first what is the introduction, what is inpainting. So basically inpainting means in historic, if you go to the back history, there are some photographs, some images. So most of the time these, by time these regions are missing. So how to recover that missing is one of the challenge. So reconstruction of the missing portion of the image in order to make it more realistic, more legible, and restored it with the unique quantity and quality. That is the challenge, that is in painting. So image restoration, basically the image in painting, as you can see here. So there are total six images, sheep and some animals there. The region is masked, the white box, we can say the mask, that is a missing region. So image in painting means we have to recover this the missing region.
Can you make it full screen, please?
Wait a minute. It is full screen. Okay, wait a minute. Sorry. So what is inpainting means reconstruction of the missing portion of the image, that is nothing but the image inpainting. So why we require the basically image inpainting is to restore the old photos and some videos. Then sometimes what happens, the unwanted object comes to the image. Sometimes what happens, the unwanted text comes into the come to the images. Then it is very necessary to remove that unwanted text, unwanted objects, unwanted image. Sometimes the blur image occurs. So again, it is very important to recover, reconstruct all the missing region of the image. That's why we required in painting. So again, need motivation, we can say. So motivation of project means there are no robust algorithm. So much research is going on, but there is no robust algorithm to produce the most realistic images or recover the whole image. The end goal of project is that it should be enough to observer should be able to perceive the fake image as a real image. That is one challenge. And with age, photographs often get damaged. To reward this, so we need a proper software to remove the damaged region or scratch region, or to remove the unwanted region, so it will be look like very realistic. Then if you take a snapshot, some unwanted object comes, then you need a software to remove that object from the image. So what are the challenges? If there is a very much large scale missing region is there, then again it is very challenging to recover that region. Then CPU and memory issues, because different data sets have different image resolution, image sizes. Then big mass issue, then normalization is the problem, and again the identifying the object in the image and how to recover that image, that is the challenges. So I have done literature survey. So learning based literature survey I have done, non learning based also. So I have find out some advantages, disadvantages. So in paper title large scale image compilation, the general they have used these all paper uses the general generative adversarial network. So I have found it advantages, disadvantages. The first paper have only implemented the deep field data set they have used, but they didn't compare the proper result. Then they have used the probabilistic GAN model. Here what they have, the advantage is the loss function works well, but they have generated the low quality samples. So like that, these are the GAN based paper. So what are the objective? We will see there is a photo restoration, object removal, text removal, special effects, high resolution, then scratch removal. These all are the objective of the image in painting. So we'll see the GAN. This is the architecture of GAN. GAN consists of generator and discriminator. The generator role is to it will take it will take a random noise and will create the sample of the images and try to create the images similar to the real images, but that is not a real images. They will try to create the images, and the generator target is to minimize the log loss, while the discriminator target is to maximize the log loss. So like that, generator and discriminator works. So discriminator will take the real data, real sample. We will send the epoch of data, each epoch having some 32 images. Then like that, we'll send it to the discriminator. The role of discriminator is to identify the log loss to maximize the log loss, and role of discriminator to identify the real and fake images. And generator and discriminator will work till discriminator find out the fake images as the real images. Till that, it will work both simultaneously, generator and discriminator. And whatever log loss discriminator got, that log loss will be again send it back to the generator. So generator will try to minimize the log loss. So continuously generator will try to create samples of the images which is real but not exactly the actual data. So like that, generator discriminator works. So for my project, I have used the performance matrix, peak signal to noise ratio, PSNR, then structure similarity index measure, and mean absolute error.
Please go to results section.
Yes. So I have taken Mysore Data Palace data set. I have collected 171 images with high resolution with my mobile OnePlus, and I have created then mask images. Then generator and discriminator I have trained. After that, PSNR, SSIM, and MAE, I got the result 16.05, 0.023, and 0.17 respectively. So these are the advantages of GAN. GAN generates the data look very similar to the original data, but there is a limitation as it is very hard to train and very difficult to manage both the generator and discriminator parallelly, because sometimes mode collapse problem occur, sometimes leaky removers, or sometimes we have to remove the leaky removers, or sometimes we have to flip the labels like real to fake, fake to real. So these are the some GAN hacks we have to use, then only we will get the result. So that is a future challenge now, to work with a different data set. Right now I have taken only the Mysore Palace, planning to take the images like Taj Mahal, then more temples, the gods, the archaeologists, how they are repairing the repair the monuments on the basis of historical data. So image, it is again challenging how to recover the human face that is damaged. So for that, we need to use different GAN hacks, like we have
Yes,
to use
please, can you
activation.
conclude it?
Yes, so these are the GAN and future scale. So real-time inpainting in one of the future scope, then object removal for object removal from videos, and we can compare the data set with other images from Kaggle also. Then Adam optimizer we can use. So this is the future scope we can do. So finally, this is, thank you so much. References, and thank you so much.
Yes, thank you for your presentation.
Okay, thank you.
Can we move on to the next one? Yes, please. Anisha, please, it's a request. Can you take care of time limitation also?
Sure, ma'am. Moving on to the next one, we have Ramesh Kuntha with the paper title Makara App, a case study in digital innovation for enhanced agricultural productivity and sustainability. So you may begin with the paper.
Hello everybody. My name is Ramesh Gunta. Let me share my presentation. Can you see the screen?
Yes, it should be.
Okay. Yeah, I'm Ramesh Gunta, along with my colleagues Aishwarya and Maya in Amrita Vishwavidyapeetham, and also my colleagues from TU Delft, Soham, Mario, and Saket. We are presenting this paper, Makara App, a case study in digital innovation for enhanced agricultural productivity and sustainability. Agenda is this one. Going back to introduction. So Indian agricultural sector contributes 18% to GDP, employs 50% of workforce, and 45% of the land is cultivated. The main point to note is that 86% of the farmers have less than 2 hectares. So because of the small holdings, they are disadvantaged due to scale, weak institutional support, and market access. What we propose is that the digital agriculture helps them to gain more advantage, same as the big holders. And in this context, we present our app, Makara app, a farm management software, and how we are deploying and what we are learning from the fields. And the related works. Digital architecture encompasses 5 thematic areas: technology adoption, impact on farmer identity, power and ethics, knowledge systems, and economic effects. Digital agriculture involves IoT, implementing IoT on the field, and cloud computing, and using robotics and big data in the fields. We have presented another paper. We have quoted another paper which has a survey of 500 Brazilian farmers in their adoption of digital agriculture. They reported that the farm management softwares are beneficial for reducing costs, enhancing revenue, and improving task management. At the same time, sensors and machinery and robots were highly valued for boosting productivity, quality, and efficiency. However, challenges are noted that adopting digital agriculture involves high initial costs, and wherever the internet is poor, it is difficult to implement it, and also lack of training and maintenance also is a problem. And there are so many, in terms of coming to the farm management softwares, there are some farm management softwares are already in the market, and such as Agrivi, Farm ERP, Farm Bright, and Easy Farm. They implement farm digitization, GIS, and various other aspects. And in India also,
Sir, the
there are
topic seems very interesting. Can we move to the actual contribution where you have contributed?
Sure, thank you. So
Yes.
the Makara app, so we're coming to Makara app. It is basically a farm management software. It involves setting up of the farm. Some core features are here. Setting up of the farm. So farmers can set up their land configuration, size and location, soil type. They can upload their test reports and add water resources. And also, apart from that, they can also manage their ongoing crops and which crops they are planting in which land and how much land percentage is used for the crop. And also they can track their budgets and expenditure as they are cultivating. And not only that, based on the crop they are planting, the admins would have already created a list of best practices: when to sow, when to do harvesting, when to do watering, when to apply fertilizer. And these best practices automatically appear in their calendar as tasks to implement. And farmers can then look at their calendar to see what to do, when to do, and they can implement their progress. They can upload their progress along with pictures and costs and various other things to track what they are doing. And most important one, which has the technology, the AI/ML included, which produces which gives them yield and revenue prediction based on the geographical data, soil, crops, weather pattern, and historical performance and market trends. And not only that, the socio-economic parameters also used. So this way they can get to know how much
Sir,
they
do
will
you
get.
have data set details from where you have taken this data?
So we are coming to the next slide where we talk. This is the data which is used for this mainly come from the government sources, geographical and soil characteristics, and weather. Weather comes from the NASA website, but we have not implemented this yet. We are going to implement and then see how valid these predictions are in this season. But we have done some historical. We have done some historical data collection surveys in the fields. So this is the summary of all the core features of Makara. And this is a data model which we used, which involves the basic seasons, activity. We capture the activities, all the farm activities possible, and we capture a series of capture the crops and crop varieties and associated growth stages and the activities to be performed in the crop using some series of tables. We capture the farmer and their demographics through farmer table, and we capture the land and activity journal. Activity journal is where farmer records what are the things he has done on the farm using the various tables. And the technology, this is basically high-level architecture of client and server and the data flow. And client side, we use Flutter and SQLite. Flutter runs on Flutter is implemented using Dart. And server side, we have Node.js and JavaScript. And MySQL is the database. We have multi-level authentication and authorization, both client and server side. And we have offline mode, which supported by the client-side database. That way, the farmer can use the app without internet. And when the internet comes, it will sync the data automatically. And we have implemented caches on both client and server side, both in database and memory, so that it feels very, very quick. The app loads very quickly and navigates very quickly. And this is our deployment story. We are deploying this app in Maharashtra in 4 dot-prone districts, Amravati, Nagpur, Wardha, and Yavatmal. So this is a multi-phased deployment approach. We are working with a NGO, Solidaridad, who has connections to the farmers. We are working with around 600 farmers, and out of them, we are, yes? Okay, so this deployment is going on for a year now. We are interacting with farmers, demonstrating with them, and then they are giving us feedback, and then we're improving the app, and it is going on in multiple stages. And the next slide shows that what our progression has been. I would like to spend 2 minutes on this slide very quickly, which illustrates the importance of interacting with farmers during the development stage. And you can see that this chart can be read as the various challenges we faced and the solutions we have implemented. So first we have had single crop per land. Then we quickly realized during our interactions, farmer has many crops within the given land. So then we had implemented how do you allocate the different area. We had implemented a slider control, which was very complex for them. Then we provided simple text boxes. Second is the risk visualization. So initially we had this complex way to show how much risk, what is the risk of getting various yields for a given farm, but they found it too much to understand this. Then we have implemented very simpler way with step-by-step process, and we have presented fewer numbers, and we have also implemented audio support for reading out the risk. So this was very helpful for them. And other one is that we had unit conversion issues because some of them use hectares, some of them use guntas, and various other things. So we have implemented a unifying unit conversion so that everything is presented according to their preference. First, they will set up their land using some units, and the entire further our metrics are represented in that particular unit they choose. And then we implemented activity tracker because they wanted not just the yield, they also want to track their expenses and their work on the farm, because that's the main thing we are offering. Because for the smallholders, they are facing so many decisions on a day-to-day, and they don't have much manpower or labor. So this technology will help them in decision making, looking at the overall picture every day, what to do, how to plan, when to shop, when to hire laborers. All of that is managed through the app. So that is what is done through activity calendar. So we hope that with all this, with all these features, Makara will become an important aid for the smallholders. And the conclusion is that digital innovation in agriculture is the only solution because the farmers are disintegrating, the families are disintegrating, which results in reducing the farmland size they have cultivating. That is why we have 80% of them have less than 2 hectares. And we have also showed that the multilingual interface and audio-based interface is extremely important. Even though there are advanced farm management softwares out there, they are not only very costly to use for smallholders, but they don't have any other interface than English. So for Indian context, we need multilingual, we need audio-based, because most of our rural population is not educated digitally also. And we are learning a lot through close engagement with farmers. And this particular season where we are deploying in Maharashtra will give us more details. We would like to acknowledge our Chancellor, Sri Sadhguru Mata Amritanandamayi Devi, who is also humanitarian and spiritual master. She has adopted 100 villages across India and trying to make them self-reliant. And one of the thematic areas, agriculture, which inspired us to take up this project and do along with Solidaridad and TU Delft. And Solidaridad is our partner in deploying this app in the rural Maharashtra. That's it. With that I conclude.
Thank you.
Any
Interesting
questions
work
you
is
have?
there you have carried. The title is also, as per the current need of the time, AI for sustainable development. So good work. Yes, thank you.
Thank you very much. Thank you.
Thank you so much for the presentation, sir. Now, moving on to the next presenter, we have Samuel with the paper title, Mine Workers Fatigue Detection Using Machine Learning Based Technique. Samuel, are you there?
Yes, I'm here. Good afternoon.
Good afternoon. You may begin with your presentation.
Okay, yes, good afternoon. My name is Samuel, and thanks for the opportunity to present our work, which is on fatigue detection in the mining industry using machine learning-based techniques. Now, that is just the outline of my presentation, and we think of fatigue as one of the key driving safety risks for employees across different industries. And particularly for this study, we're interested at the effect of fatigue on employees in the mining sector, where it has been found that it is a major contributor to accidents involving mine truck drivers. And we know that some of the consequences for occupational injuries and accidents, which may result as or due to fatigue, may be loss of life, for example, and other issues like functional limitations and economic and social costs. Now, there has been an emergence of predictive fatigue management solutions in various industries. For example, if you look at the construction, look at road transport operators and in the health industries, and this is mainly due to the advancement in smart mining technologies. For example, if you're looking at the mining space, and we have seen machine learning-based solution for occupational safety among other mining operations. Now, in terms of the related work, there's 4 categories of fatigue detection techniques. Some are based on images and videos, some based on biological signals, some based on vehicle movements, and some based on some taking a hybrid approach where they sort of combine 2 or more of those techniques that we have. But if you look at the image and video-based analysis, most of them have been evaluated in control settings, so that is using mostly simulated data. And if you look at biological signal analysis, which are found to be more accurate compared to the others, the sort of more intrusive in nature, and they require, for example, wearable sensors which can be distracted to the driver, for example. And vehicle movement analysis has been found to be the least accurate and least reliable of the four approaches that we have. But thinking of the hybrid technique, which would be ideal, obviously, then there's issues of hardware complexity and all that.
Can you please move on to the methodology where you have contributed?
Yes,
Yes,
methodology.
please.
Then yes, in terms of the data, we have used two data sets, which is one is an open source data, which is the yawning detection data set, and we also then used a real life data set, which is which we collected from, or which we got from a local mining company, and that data was collected through the advanced driver assistance system. And then obviously we then needed to do some processing in terms of face detection and facial landmark extraction. And then the two features that we looked at in this case was one based on the eye movement and one based on the mouth, because I mean that's, look at the literature, those some of the features that you can use for fatigue detection. And then we then used three machine learning algorithms or classifiers for fatigue detection: SVM, random forest, and KNN. And then at the end, then we did a binary classification whether a driver is fatigue or non-fatigue. Basically, the data set that we used from the open source data, we used the 207 videos, and we had then 46 videos from the real world ADAS data set. And obviously they vary in terms of, for example, the recording set and environment, the duration, and the data labeling and the condition or the lighting conditions under which they were recorded. Now, in terms of the performance evaluation and result, here we show the result of our three machine learning classifiers. And we then see that the recall values for all the three models are quite high than the precision, which is an indication that our models are more tolerant to true positives in fatigue detection. The results, we also see that they are quite, they compare very well with the results of similar studies that use the yawning detection data set. And the challenge, obviously, for real data set that we picked up is the low image resolution, for example, in the sense that some of them, because recorded under different varying light conditions, and obviously due to poor and all that, or due to poor lighting, for example, then that means that affects the face detection in those videos. So we needed, if you look at, or if you think of the simulated data, your Hawk plus SVM does well for that, does well for the simulated data, but it doesn't perform well on the real world data. So we needed to then use deep learning based face detector like CNN, which obviously then offers significant improvement in face detection. But obviously then that comes at the cost of reducing the system's computational speed and increasing, of course, complexity. Now, in terms of the conclusion, the significant contribution of our study is the use of a real-world data set to evaluate the performance of fatigue detection models, because if we look at the literature, most of the studies relied on simulated data, which of course doesn't bring in some of the aspects that you do encounter in real-world driving conditions or situations. In terms of the performance, obviously we see that they do perform well with prediction accuracy of over 90%. And obviously there's some issues, particularly when you look at the face detection, and obviously we highlighted those challenges already. And one possible future area of research that we want to look at is fatigue detection model using videos with more than one subject, where you now want to pick out the driver and see whether they are fatigued or unfatigued, because what we have done in this study and what has been done in previous studies is basically just videos with one face. And with that, I thank you and I welcome questions.
Yeah, on one of the slide you have mentioned that you have used a real-time data set. So any special website or what you have used for fetching the real-time data set for this?
I beg your pardon?
Are you getting my question?
Can you please just repeat your question?
Yeah, on last slide of the conclusion, you mentioned that you're fetching the real-time data set, right?
That's correct.
Okay, so how you're fetching that data set, from where you are scrapping it, which websites you are referring, or anything you are referring, please tell us.
No, the data set was obtained from a local mining company, and they sourced it from their ADAS system.
I see. Okay, okay. Okay,
Yes.
fine.
Mm.
Thank you so much for the presentation.
Yes, thank
Welcome.
you so much.
And now moving on to the last presentation of this session, we have Martin with the paper title Technology's Green Revolution, Advancing Sustainability in Industry and Society. You may please start your presentation, sir.
Is my screen visible, ma'am?
Yes, it is.
Okay. Moving on to the presentation, there is the table of content, introduction, methodology, literature review, implementation of sustainable technology in an industrial environment, impact of sustainable technology on industry, environmental conservation, industrial transformation, and conclusion with references. So the introduction talk about just okay. The introduction talk about in recent years, there has been a rise of interest in connection between technology and sustainability, especially in the light of environmental preservation and economic resilience. And this literature also presents a survey that explores the diverse aspects of sustainable technology. And the study also starts by going over the fundamental ideas of sustainability and sustainable development, stressing how crucial it is, and the application of sustainable technology in industrial settings and its possible advantages. So moving to the next slide, here's the methodology. The methodology talk about this research paper was done collecting secondary data based on industrial report, academic publication, and pertinence websites, and some scholarly publication and report published by peer-reviewed journals, and also conferences. And the following keywords were used to search academic publication in the web of science, technology, sustainability, environmental conservation, industrial practices, and climate change mitigation. And we also use search for grain literature and industrial report on Google Scholar and other pertinent organization websites. So moving on to the next slide, this is our literature review. The literature review compares like make similarity between sustainable technology and sustainability, that they are closely related concepts that have been thoroughly explored in environmental.
Can you make it full screen, please?
Okay, ma'am. Is it clear now? Okay. So
yeah, please go ahead and move to the actual contribution where you've contributed.
Okay. So moving on to this, like implementing sustainable technology in an industrial environment. So this is an important topic that have been covered in an earlier literature, is the sustainability environmental industrial revolution. So there have been some controversy over this, whether it should be in an industry for a long-term effect on environmental sustainability, or it should just be like research that people just give opinion. And also, we talk about the ecological sustainability and the study that concentrates on aspects that is connected to it. The study contends that new businesses and startups include their plans and strategies for fusing production and environmental sustainability within the industry. So it is very important. And a sustainable technology aligned with sustainable development objectives and encourages a shift in society towards sustainability. He also discussed about the technologies that work in answering for achieving human satisfaction and economic growth while respecting the ecosystem during the harm to it. And also, there are finite amount of natural resources in the world. As long as we have left sufficient space for them to regenerate, some resources like trees and wildlife are renewable, and the overuse of it may likely damage our ecosystem. And also the impact that this technology, sustainable technology, has on an industry or in an industry. Some literatures has indicated that practitioners in developing nations share a similar interest in these techniques. Companies can achieve sustainability with new emerging technologies by implementing the current economy in the industrial revolution 4.0. And this is because of inadequate infrastructure and labor shortage and sustainability of this technology. Adoption is constrained in developing economies. So digital technology adoption may provide solutions for various problems that traditional businesses face, including supply chain management, organizational structures, and production processes. And also the Internet of Things have also emerged: blockchain, AI, augmented reality, cyber physical systems, big data analytics, and cloud computing. These are key technologies that bring about this industry 1.0 version of life. Moving to environmental conservation. An environmental conservation is an ecosystem, is a collection of natural resources, artificial, chemical, and biological components that allow living things to live, change, and grow. All of natural resources, including cultural heritage and human infrastructure, essential for social economic activities is in this particular definition given by the International Union for Conservation of Natural Resources. An organization environmental sustainability reveals its dedication to cut down waste and achieve energy efficiency and reduce carbon emission. The water use also can be reduced, and other important things that are related to conserving conserving the environment. Climate fluctuation, droughts, and other natural calamities that threaten humankind have made environmental preservation increasingly crucial globally. Now that the world is aware of climate change, that the climate change is a real problem rather than myth. Businesses and other stakeholders must immediately commit to adopting environmentally sustainable practices. And these are things that if the industrial environment conserves the environment, these are things that they will benefit. Things that they will benefit. It will reduce costs, it will improve their brand reputation, It will have some resilience to supply chain risks, climate change mitigation. It will also help to mitigate the climate change, and it will also have renewable energy deployment, improve in energy efficiency, and it will also help in growing new forest and also have some sustainable land management. This is the digital industrial transformation. The widespread of digital technology encourages the impact, doctrine of the innovation and industrial chain, which helps the manufacturing sector move up the value chain while simultaneously lowering research and development expenses and increasing research and development efficiency. The manufacturing sector must use flexible production to meet their customers' various industrial needs. And their production process should be optimized via digital technology in supply chain. And they should also have some digital technology that will help their clients and boost the vitality of their services that they are offering to their clients or customers. Furthermore, when cutting-edge technical advancement and are integrated in every link in the supply chain, established industries, they can ultimately transform production and generate new manufacturing sector. So in conclusion, this literature, this particular paper has offered a thorough analysis of the connection between technology and sustainability from the social, economic, and environmental perspective. And first, the assessment emphasized the importance of incorporating sustainability ideas into new technology, especially in industrial settings. Sustainable manufacturing methods are essential to minimize environmental effects and maintain long-term economic viability. These practices include use of renewable energy resources, energy effective technology, efficient technology, and waste reduction techniques. And second, the assessment emphasizes the importance of adopting sustainable technology in tackling global issues like climate change and environmental degradation, sustainable land management practices, afforestation, reforestation. It can help to mitigate the negative impact of climate change by improving soil health, sequestering carbon, and conserving biodiversity. And these are the references used. Thank you.
Yes, thank you for your presentation.
I'll stop sharing now.
Thank you
Yes,
for
you
the
can stop
presentation,
sharing.
Martin.
Yes, yes, please. Anisha, we can move on. Yeah, please.
Okay. So moving on for the conclusion of this session, and I sincerely thank all the authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. And we, on behalf of the whole team, thank you for your support during this 9th version and all the previous 8 versions of the conference. And we will be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICT4SD 2024. I would also like to thank our session chair for chairing the session, and here is a small token of appreciation on behalf of the team of ICT4SD, Global Knowledge Research Foundation, and partners. So thank you so much, ma'am, for your valuable presence. Would you like to give a closing remarks to all the participants?
Yes, thank you so much, Anisha. And of course, I just wanted to give my best wishes to all the researchers. So, yeah, please keep working. Yes, thank you so much.
Thank you so much, ma'am. So at the end, I would just request you all to please switch on your cameras for a quick snapshot for this virtual conference. Okay, thank you so much, everyone. It was a great session. Hope to see you all soon. Bye-bye.